Okay, so I'm going to take a quick look at the TG320 function generator. The function generator provides us with waveforms that we can use as the input of our circuits, for example amplifiers, in order to monitor the performance of the circuit. It provides three different functions or three different waveforms. We can have a sine wave, a square wave, or a triangular waveform, and we have the three different selection buttons up here under function to decide which we want to we pick the most suitable waveform for our device. There are two things that we need to consider for our waveform, and that is frequency and amplitude. So frequency, the number of times the waveform occurs per second, and our amplitude in terms of size of waveform. So we can make certain adjustments to the waveform that we get from our frequency generator or function generator, and then we can go on to monitor that onto the oscilloscope, which I'll show in the next video. A couple of things just on the initial setup to ensure. Just ensure that your external counter is set to off. Ensure that your symmetry button is set out as well, that it's off, and ensure that your DC offset is at the 0 setting. It's centered. All of these things would have an effect on your waveform, and perhaps not view the sort of way you'll not get the waveform that you think that you're getting from the measurements on the dial, or you'll not be able to measure it in such a way. Something else to consider as well here is this here, the peak to peak / RMS. That's just a way that you're a particular value or a particular way that you're measuring the waveform, whether it's from peak to peak voltage or RMS voltage. We prefer probably use peak to peak, would probably be the most suitable for any of our functions. So in terms of setting up your waveform with your correct frequency and your amplitude, the first thing we'll look at is the frequency. So the frequency here, we have the different frequency ranges across the top, and basically when you're on each of these ranges, that's the maximum frequency that the generator can output at that particular moment. So here, for example, we're set on the 3 kilohertz range. That means it's the maximum frequency is 3 kilohertz that can be output. So you need to consider which range you should be on, depending on what frequency you've been asked to provide for your circuit. Then the other consideration is the amplitude. The amplitude has two attenuation buttons here, and an amplitude dial here to set up to fine tune your amplitude to the value that you require. So if, for example, I want to set up a waveform, say of 10 millivolts peak to peak, so you'll see currently it's sitting at 2.3 volts peak to peak. If I bring the dial down to the bottom there, as far down as it'll go, I'm only getting 1.5 volts peak to peak, so I'm going to have to adjust the attenuation here. So I use the minus 40 dB, and you'll see there I've gone down to 15 volts peak to peak, and when I press in the minus 20 dB for additional attenuation, I'm down to 1.5 volts peak to peak millivolts. So now I'm in a position where I can adjust this for the 10 millivolts, sorry, peak to peak that I'm setting the function generator up for. So in order to get your voltage, just to recap, or your amplitude there, it's a combination of the two attenuation buttons, depending on how high or low the range is that your voltage lies, and then to fine tune it in using the amplitude dial here. Then say I want to set up a frequency. Now that I've got the amplitude set up, I want to set up a frequency, say of 1.5 kilohertz. Well, I look at the range. First of all, look at the frequency ranges. So 1.5 kilohertz lies between the 300 hertz and the 3 kilohertz range, so I make sure at the 3 kilohertz range pressed in. That's grand. And then I go over here to the left hand side dial, and I then adjust the frequency here to get till I get 1.5 kilohertz. You'll see at the minute there it's reading 823, and you'll see hertz there. So I'll continue on up, and you'll see there I've gone to 1.1. It's changed to kilohertz. So I'll go on up to 1.5, and that's not too bad there. 1.498 kilohertz. As far as the different connectors here that you'll use, you're going to use the main out 50 ohm. So it's the connector to the right, and you'll use an oscilloscope lead to connect in there. So the next thing that I'll do is I'll show you how we would actually measure that waveform on the oscilloscope, and how to set the oscilloscope up in order to do that.